Good morning, ladies and gentlemen. Welcome back to Principles of Psychology. Today we are going to do a little bit about reflection and some of the properties of reflection. We're going to look at it through light. So we're going to see how things reflect through light. I know what you're thinking, Mr. Belts. I know how this works. I never knew it. Well, one of the things I can tell you is that what you have learned from what we'll call anecdotal experience is probably not 100% correct.
No matter how far or how close you are to a mirror, you are always going to see the same amount of the reflection. Well, I know what you're thinking. But Mr. Belts, when I look into the mirror in my bathroom, when I'm closer, I don't see as much of my body as I do when I'm farther away. Well, there's a little thing of the sink top being in the way for that and the vanity. But in a regular mirror, hanging anywhere, you will see exactly as much up close as you do farther away. The rays that are reflected are always going to follow the law of reflection, and it's always going to give you the same image no matter how close or how far away you are.
But what we're going to do is pretty simple. We're going to get a mirror. We're going to get some clips to hold it up, which I have here in the picture. And the first thing we're going to do is we're going to take a pen or a pencil, and we're going to trace right where the interface of that mirror is. So we're tracing right along the bottom of that thing. The tricky part is letting go without it moving anywhere. The next thing we're going to do is we're actually going to shine some light from a laser onto the mirror. So I'm going to drop these lights here so we can see the laser on the paper. And so a nice purple laser, you can see it there in the mirror. But we're going to do it down here close to the paper. Okay, now what you can see is that it makes a V. It goes into the mirror and it reflects back out. Okay, so what we're going to do is we're going to actually trace this line. I'm going to switch hands. I'm way better doing this with the writing portion with my right hand than my left hand. So we're going to trace that light, and then we're going to have it reflect out. We're going to trace that one as well. Okay, so what we're going to do at that point is we're going to look and we're going to see what we can see. Now, what I can tell you first off is that I didn't do a very good job. You can see that these don't actually connect there where they are. But for our purposes, it should work. The next thing we're going to do is we're going to take a protractor, we're going to put it right here at the interface, and we're going to draw what we call a normal line. Now, you should remember from your vocabulary that a normal line is a perpendicular line. So we're going to draw a normal here where this thing intersects. And since a normal is an imaginary line, we're going to make it a dotted line. Now we're also going to do the same thing for this other one. Let me line it up. And we will make it a 90-degree line. Because a normal line is 90 degrees to the surface. That's why we call it normal. And we will trace it out here. Now the next thing I'm going to do, because I realize that these lines are a little bit short, is I'm going to extend them. So that was extended, and so is that. Okay. I'm going to put a little arrow here on it, put an arrow here on that one, so you can see what's going on. Now what I want to do is I want to measure this angle. So we line back up, make sure we're on our line nicely here, and we're going to count it from our normal. So let me get my hand out of the way, and what we're going to do is we're going to start at 90, and we're going to count to where we get to. So we get 10 degrees, 20 degrees, 30, it looks like 31 degrees. So we're going to write 31 degrees in here, and we're going to slide this over, and we're going to do the exact same thing with this one. So again, we start at 90, we go 10, we go 20, we go 40, and that looks like a 1. So what we've just done is we have experimentally worked through the law of reflection. And what it says is the angle of incidence and the angle of reflection are equal. So the incoming angle, which is the angle of incidence, and the outgoing angle, which is the angle of reflection, are exactly equal for a plane mirror. Now we're going to call this a plane mirror because it is a mirror that exists only in one plane. You do have curved mirrors. Those react a little bit differently. That's why the mirrors that you have on your car, say objects really closely to here. That's why in stores where they have the security cameras that are behind the mirror, you will notice you can see way more in that mirror. And that's because some of the properties of a curved mirror, but reflection works exactly the same on those as it does here. So this law of reflection, saying that the angle that it goes in at and the angle that it comes out at are exactly the same, will apply to any mirror. Part 2 of this lab starts pretty much the same way as part 1. We've got our mirror right there in the middle of the paper. And we're going to, again, trace the bottom of the mirror. So when we do that, we do this so we have a starting point and we know where our interface of the mirror is, again. So we've got that. Now, in this one, we're going to find out how far away objects are from this mirror. So what I'm going to do is I'm going to use a couple of these expo markers. So I'm going to place an expo marker here. And then what I want to do is I want to place an expo marker behind the mirror. Before I do that, I'm going to trace around the bottom of this expo. Okay, again, we want to know the placement of it. So what I'm going to do with this second expo marker is I'm going to try to place it behind the mirror in a way that it will complete that image no matter where I look. You'll understand what I'm saying here in a second. So I'm going to look and I'm going to try to place this in a spot where it completes the image. Now, from where I'm looking, it completes the image. From where you're looking, it does not. So, I'm going to move this marker until it does. Again, it's working from mine, but not from yours. So let's see about moving it inward a little bit. Now, from my vantage point and from your vantage point, it looks like it completes it. So what we're going to do is we're going to take your vantage point and we're going to move it so that you can see what I mean. Notice the boot gap is still completing that marker in the back, no matter where it is. Okay, so any place that we're looking from, it completes that image. This is exactly what we're looking for. So now with that one that's in the back, we're going to do the same thing as we did for the one in front. We're going to hold the top of it so it doesn't move, and we're going to trace around the bottom of it. Once you do that, you can remove both markers. And now I'm going to remove the mirror. So I'm going to turn the light on so you can see a little bit better. Now, the difficult part is actually measuring. So let's say some of you guys here should be able to measure fairly well. I know in science class you're used to doing things in the metric system, but what we're going to do here is we're going to stick with the system that you guys are familiar with. So you're going to look at these circles, and we're going to try to place a dot, let's say somewhere close to the center of it. Doesn't really matter if it's off a little bit for what we're doing, but do your best. And now what I'm going to do is I'm going to measure from the center to the mirror. So for this one, it looks like it's about 2 3/8. Okay, so we'll call this 2 3/8. We'll draw that one. Now I want to do how far away the other one is. Okay, so again there, so you can see it a little bit better. Starting right on there, that's 2 3/8. So we're going to do the exact same thing. We're going to put this here. We're going to maybe from the line to the center. Draw a line. And what we found here is that it is again 2 3/8. And then that looks like an 8, so let's get rid of that. So 2 3/8. Now what we're learning from this, or what we should understand from this, is that the image is what we're seeing, and the object itself is the physical object. But what we're seeing is that the image appears to be just as far into the mirror as the object is away from the mirror. So if you are 2 feet from a mirror, you look like you are 2 feet into the mirror, which means your image would be about 4 feet away from where you are. So that's one of the characteristics of these images that are formed, is they're just as far into the mirror as they are away from the mirror, as the object is away from the mirror. The light reflects out the same way it reflects in. And then just a little bit of a side note type of thing, like you guys have heard of two-way mirrors and things of that nature. Well, how do you check to see if a mirror is a two-way mirror or if it's a regular mirror? Well, the way mirrors are made is they have the reflective coating is typically on the back. Easiest way to do it, you get a piece of glass, you put a coating on the back that's reflective, and it will do what you need it to do, and then reflect it back. But that means that there's going to be a gap between the mirror itself and the image. So when you put something up against it, you should see space between it. See how there's space between the image of the Costco card and the actual Costco card? That space is good. That's what you want. If you put something up against the mirror and there is no space between the reflection and the actual object, then that is a mirror that has a coating on the front surface. The main reason they do that is so that the light reflects off of the front, which allows some light to transmit through it. That's how you get the two-way mirrors, like in the movies when you see a police observation room and things like that. Those two-way mirrors are going to have a mirrored coating on the front, and it's going to have no spacing between the image and the object. So just another little piece of information. Next time you're around a mirror, you can do that. You can put your finger up against it. I like to use things with straight lines because that makes it way easier to see. Thank you for going with me, going through 2 parts of our reflection lab here. Hopefully it was educational, and I will be talking to you again soon. Have a good day.